It's an honor to be here. And actually, I joined Tsinghua just a couple of months ago. So I was pretty new here, but I have been excited. So I'm sure you also learn a lot about Tsinghua, about China. And so I am originally from China. So I left China in 1988. So lived in Europe for over 37 years. And I have had different jobs, but here I list 2 jobs. One is Tsinghua, which is a pretty new job. The other job I had was in Paris, actually. I was the head of International Science Council in Paris, which is the biggest international organization in science, coordinating national academies around the world, also disciplinary scientific unions in different disciplines, such as physics, everything you can imagine, chemistry, mathematics, everything. So I listed that position here because what I'm going to tell you will be deeply biased towards that vision. We all can have different visions of the world, different views on the world, but I'm really, I consider myself as a world citizen. And also I consider myself as one scientist that is working for the whole scientific disciplines, not only just my own, which is in climate. So in that perspective, I was thinking hard actually to pick up a topic in this occasion. And I thought that would be good because this will give you a view on the whole system. It's not just one discipline. At the same time, this is something I really have a lot of insights I'm going to share with you. I know a lot of great people. I know the story behind. We could also have some conversation afterwards, after my talk. You can even raise your hand if you have an immediate question during my talk. As Professor Huang said, that this kind of summer school is very important. I was thinking back in my career as a scientist, I would say that the most enjoyable time is when I was a student, especially in summer schools. So I went to a lot of summer schools in Europe, in other places, and where I meet friends. So of course, you will learn a lot of things like today, but I think the most important thing is that you meet friends, you meet a different culture. That will be long-lasting, will have a long-lasting influence on your career, on your thinking, also you as a human being, I would say. At least that happened to me. So I would say enjoy the time, not only studying hard, reading books, attending lectures, but also making friends, drink beers. And my supervisor is a Nobel laureate. I'll tell you a small story. And Paul Kutzen is his name. I will show a picture later on. So one time I attended summer school with him. He was a lecturer. I was a student. That was in Austria, in the mountain region, beautiful place. And one afternoon, and we were listening. He gave a lecture, of course, then some other professor gave another lecture. So we were sitting in the audience, and after 20 minutes or so, he told me, this is so boring, because the professor there was not good. He said, let's go out to have a beer instead. So we went outside the lecture. I'm not encouraging to do that. But it was just interesting that we went out, and then we see a small church. We walked in the church, and in the church, there were some people buried in the church, in the garden. And we saw one name, that is Schrödinger, the great Nobel Prize winner in physics. Oh, I said, okay, he was from that small village. And we have a lot of conversation about him, about this physical theory. And but he said to me, well, we are working in climate science, we'll never get the Nobel Prize. And then some years later, he did get Nobel Prize. And I was actually one of the first who got to know, and because the journalists tried to contact him, but never, because he was on holiday. He did not tell anybody he was on holiday, where, and so on. So the journalists cannot get hold on him. And so actually he did not know he got 2 days after he got Nobel Prize. Typically, as you know, that when we decided on Nobel Prize winner, we pick basically a few of us in the Royal Academy, Swedish Academy of Sciences, in which I'm a member also. We go to a room, we take the phone, we call this person, no matter what time it is. But we tried, at that time I was not in the academy yet, but they tried to call him, but never succeeded. And at that time we don't have email or things. We have something called a fax. I don't know if you have seen the fax machine. So I sent him a fax actually, immediately when I got the news. So you did get the Nobel Prize. So when he got back in the institute, he saw a pile of papers or fax. And he opened the papers, and my fax was the first one. So he told me later, and you are right, I did got Nobel Prize. You were the first one who told me. So I was happy with that. So that's a small story, but let's go to the what I'm going to talk about today. So basically, I'm give you talk a little bit about the big challenges we are facing as a society, not just in science, but of course, then I will focus on science, on something called Earth system science, which is the heart core of science dealing with environmental issues. And I will tell you something about the history of that science, and also for just 5 grand challenges we are facing in Earth system science. By the way, I'm coming from the Department of Earth System Science in Tsinghua. This department is the first ever department in Earth System Science in China, although it is pretty new. So you can see that Earth System Science is something new, actually. I will tell you a little bit of the history on the international level. And I'll give you some of my own research as examples to illustrate what Earth System Science is about. And finally, I can make some final remarks, basically telling you a little bit about the future perspectives in Earth System Science. Of course, actually in science in general, because as you, for example, AI, you have heard, Professor Huang as a medical professor also mentioned AI. Of course, in Earth System Science, in other sciences, there are a lot of applications of AI too. So I will give you some thoughts on AI and big data, because behind the AI, usually there's something in the beginning more important, that is the big data. So if I ask you that question, what is the 10 most important challenges the society is facing, you probably will give me some of the answers on the list. So these are the answers from some Nobel laureates, 50 Nobel laureates. So this is how they answer that question. Number one, as you can see, I highlighted a little bit, the population, which also has something to do with medical, of course, the aging, and also the environmental issues. That is a big issue. You are lucky, actually. Now this time you came to China. I can tell you some 20 years ago in Beijing, that was a totally different story. The air quality was very poor. And at that time, I, as an atmospheric scientist, I made a prediction. I think China will take 40 years to fix the problem. That was my prediction. Today, I'm happy to confess I was wrong. It took less than 20 years, actually, for China to solve the problem, which is great. But anyway, environmental degradation is considered as the number one. You can see, the nuclear war. I remember, because this survey was done some years ago now, to 2017. Can you imagine that? I think nobody thought about a nuclear war at that time. But these are really great scientists. They're already foreseeing that's still a big challenge there. Today, I think everybody sees the big challenges. That can happen anytime, because I just came back from Europe. We know that even Sweden is preparing for a war. Can you imagine? Sweden used to be a neutral country. So the world is changing. It's changing very fast. My own supervisor, Paul Coulson, I told you him, he got Nobel Prize for the discovery of ozone hole. He had even more important discovery, I would say. if he's still alive, we should give a Nobel Peace Prize to him, because already some decades ago, he made some study on nuclear war. As a student, I even helped him to do the calculations. Of course, we cannot really experiment nuclear war, the consequences of that. So we do that in the computer model. So at that time, he put the nuclear weapons into the computer model and saw that if we use all of them, the world will be entering a nuclear winter. The whole climate will be changed to a very cold winter. It will take a long, long time before we can recover from that in terms of climate. That scenario, I will say, not like just warming 2 degrees, but that scenario about nuclear war has really helped world leaders to think carefully about nuclear war, I think. So helped promote peace, in other words. In my eye, that is a great contribution to humanity. But other challenges, I don't know if you agree with them. Facebook, for example, is also considered as a challenge. Everybody is using it. Of course, you have different versions. In China, we use WeChat, it's the same. And I think we are going to see more and more challenges with that social media. Or the young kids, if you look at how many hours they spend on mobile phone, and that's going to change the world, also change many people's and physical conditions, as well as mental conditions, I would say. So there is also something called the World Economic Forum. That is the meeting, basically the business leaders, politicians, they meet every year in winter in Davos, Switzerland. I was there in the winter with the president of our university, Tsinghua University, last winter, January. And the summer is in China. And I was there also just a couple of days ago. These meetings are very important because they're setting agenda. They're setting agenda for politicians, for business leaders, for citizens, and also for scientists. What are the biggest issues we need to deal with? And if you look at, they have kind of 1, 2, 3, 4, 5 different categories, challenges. And the first, economic, of course, they are very much concerned with the economic development. And also the green ones, environmental, you have also geopolitical. You can see yourself that with the years, the challenges has been changing, the colors has been changing. Since about 2011, the green ones, environmental challenges, are actually dominating or always there. It's changing now. Geopolitical tension is again very important. And I had a problem with my computer this morning. So the slides was not really updated. I actually updated this diagram yesterday night at 2 o'clock. But this morning, I don't know what happened with my computer, and I have to use an older version. But anyway, I can tell you that now the climate change, the green ones are still there. The extreme events, extreme weather events such as the hot weather, heat waves, are listed every year for the next year and for the next 10 years. So I think climate still is a big challenge. So what is Earth system? I'm going to say something about Earth system science. And what is Earth system? Well, this is the definition we gave in 2010. And actually, you can see the author here. We have 2 Nobel Prize winners in the author list. One is Elinor Ostrom. She is the, oh, this is a little bit weak. Anyway, it's highlighted in red. She is the winner for the economic prize, Nobel Economic Prize. We have another one, Y.T. Lee, and with chemistry laureate. So we define the Earth system as you can see, actually, physical, chemical, biological, and social components. I think some of you may have some knowledge about earth science. Earth science typically includes like my own field, atmospheric science, ocean science, geology. These are typical Earth science. But here you can see we also include actually human, the social dimension. That is very important, and I will tell you why this is important. And then another keyword here is system. We typically consider our discipline as one component, and we focus on that. That is important for the studies. But in real world, we have to really put things together. So this is a picture basically showing this idea. We need to take a look at the whole thing as one system. And then in Earth science, there is a long history. Many people believe that Earth science is just the geology, studying the long history of the Earth. But Earth system science is different. The most important difference is that we added humans. And let me tell you, if you look at the history, the geological history of the Earth, it is very, very long. Where we have humans, well, if it's only at the very, very end. We have 1% of the 1% of the time where we have humans. So human is a very later comer to the Earth. But it has actually been very important. I will show you a little bit shorter because, the whole history of the Earth is too long. If you just look at last 100,000 years, so this is a diagram showing you the global temperature, basically, global temperature compared to the temperature today. And if there's zero, that is today's temperature. That is the anomaly, we call it, the deviation from today's temperature. If it's minus, the temperature is lower. If it's plus, the temperature is higher. And you can see that actually over the last 100,000 years, the temperature has been fluctuating a lot. Only in the last 10,000 years, we have a stable climate. The last 10,000 years. And during that period of time, we started to see civilizations. So you can immediately realize the importance of climate to civilizations. So for every civilization to develop, you need a stable climate. That is quite simple because, because today we know that civilizations build on agriculture. We need to produce food. Before that, we are hunters. We're just hunting the other animals. And then if weather, climate is changing, then we have to move to a new place, etc. But only when we have the agriculture, we can stay in the same place. We can build houses, we can build small communities, we can build cities. And in city, you can have different people like you, like myself. We don't need to actually work on agriculture to produce food. We can stay alive because there are other people who are supporting us. We can have artists, we can have scientists, etc. So only with this type of people in society can develop actually, together with, of course, agriculture producers, industry, other sectors. You can develop the whole civilization. But what's happening now is that we are disturbing that system as human. We put a lot of carbon dioxide, as you know, for example. If you look at the carbon dioxide curve in this diagram, which is about 500,000 years, only in the last 200 years or so, with the industrialization, we put a lot of carbon dioxide. You can see almost a vertical increase. So that change, that speed of change, we've never seen before. And also that level of carbon dioxide, we've never seen before. Actually, it's much longer, about 2 million years. We have not seen that before. So that poses a lot of challenges to the Earth system. And we know that with that we have, actually this red curve is a very famous carbon dioxide measurement in Hawaii. I think it's so iconic, and many people believe it. Even for that measurement, the person who was a PhD student, David Keeling from the US, he started to measure carbon dioxide in Hawaii. And that curve actually has become the strongest evidence of the changing environment, the changing climate. And many people believe that he should get the Nobel Prize for that, because this is so important curve. And also, certainly, I can tell there was a news that under the current U.S. administration, maybe they will stop the measurement of that station. So that would be a tragedy. We'll see if that happens. But anyway, that has played a very important role, really telling us we are rocket high. And so our job, your job, is to bending the curve within a reasonable time. That's why we need to cut the emission of greenhouse gases. And by the way, also not only carbon dioxide and greenhouse gases, we connected a lot of other data. This is the data collected by the international program IGBP. You can see, you don't need to see exactly what they are, but you can see all the curves are picking up and accelerating after the 1950s. So we call this period as a great acceleration period of time. And this is also a very famous curve in my science, climate science. So you can see that basically the climate, natural climate temperature has been decreasing over the last, this curve is 2,000 years. But then only in the last 200 years or so, the climate, the temperature here is increasing. This is very famous, called hockey stick. It's the first, has been published by a Professor Michael Mann in the US. And he's also a close colleague of mine. We admire his work. But also Kaufman is another professor in the US who also put all the evidence together, produced this curve. So you can see that we really, as humans, really disturb the system within a short period of time. This is a picture I promised to show you. This is Paul Coulson. That was me in 2012. And I was invited to give a talk in KIT, which is a research institute in Germany, Karlsruhe. And just before my talk, and he walked in without telling nobody. He did not inform anybody. He took a train, traveled 2 hours from Mainz and to this city to listen to the talk, to have discussion with me on Earth system science. And with that, you can see the importance of the Earth system science, and also you can see the passionate scientists like him. He has retired at that time already, but he still was very keen to discuss things with young, well, me as a relatively young scholars. And more importantly, I will say that another thing, he should get a Nobel Prize, which is he invented a concept called anthropocene. Have you heard this term? Yes. So that is, I think, totally changed our mindset. I know that because I was working as the coordinator of global scientific community for the UN. So basically, I was a speak person for global science in the UN system for a couple of years. And when I talk to the politicians around the world, and this word is very important. And so I can really say that that has changed our mindset. I'm sorry. So what is the Anthropocene? Well, Anthropocene has 3 characteristics. It's about human influence. And number one, it is, of course, you could say, well, human, at least 200,000 years we have people in Africa. We know that. They are humans. But the extent of the human and human activity has never been such a big as today. So the extent, the second one is the speed. I already showed you, just, changes within a short period of time. Of course, the nature changes anyway, but it's much slower. Number 3 is coupling. We have never been so connected with each other as today. Through transportation, through internet, etc. So if you look at, for example, the whole wild animals in the world, especially mammals, you can see that actually today we have 60% livestock and also 36% human. So only 4% are wild. And you can see that actually 70% birds are chickens. Chickens are basically produced by humans in a larger scale. And so only 30% are wild. So we actually, human made a lot of, I can give you a much longer list of things that human has done to the earth. And the connection, you have shipping, you have internet, you have also flights. Can you imagine every few seconds you have one flight, a big flight, taking off somewhere? And the fact you are here in China, and also I still have to travel a lot. I mean, it's for many my colleagues. Yesterday I was in Shenzhen, 3.5 hours flight, and I left home in the morning. I got back in the evening. I gave a talk, meet a few colleagues. So all these are possible with today's transportation system. You have the energy fluxes, which is an engine for the development. You also have the internet, the communication system, which is connecting of each other. This is just Facebook. If you do the similar plot for WeChat, you will have an even more impressive picture. And so there's no doubt we have been in something called Anthropocene. And this is a two diagram showing you that we have Earth system, which typically could have different equilibriums. If you study physics, you know the equilibriums. So you can change. And in one state, we call it Holocene in the geological time. So the climate is basically fluctuating within a certain range. And then now we are making the humans have such a big impact that we are probably will be out of this natural variability. We're going into a different world. And indeed, I think this is for the classroom thing, whole classrooms. Or maybe I took too long time? No, we still have some time, yeah. So I told you that actually in 2012, there's a big meeting called Rio +20. Anybody have heard that name of that meeting? No. This is a meeting for politicians to meet, for heads of the states. And a couple of decades you will meet again. In 2072, they met the first time in Stockholm. I was the starting of the environmental consideration in the world. After 72, you see that different countries establish a ministry for environment. In the UN system, we have established something called UNEP, United Nations Environmental Program. Before that, can you imagine, before that there was no consideration of environment. And we just basically have this industrialization, and we want to develop economy and so on. And 1972, there was also a year that there was still a lot of war ongoing. I remember if you have access to YouTube, you can go to the YouTube to try to find the information of the 1972 Stockholm Environmental Conference, because this is a landmark event that changed the world. It was initiated by the former Prime Minister of Sweden, Olof Palme. He's a great politician, and he made a very good speech, opening speech in that conference. That conference changed the world. And so after that, we have Rio in 20 years later. Then, after Rio, 20 years after Rio meeting in 2012, we have Rio +20, another big summit. And for that summit, we have prepared some scientific input for the politicians to consider. And I was in charge of preparing that document. And I remember we made a 35 page or something report. And I was told they were only impressed by that diagram, so only one page. So that is the one of the lessons I have learned that when you talk to politicians, you should make very brief. You should also make nice figure, not a lot of text. They don't have time to read text. And that diagram is actually made by a group of people mainly from Sweden again. It's a good friend of mine, Johan Rockström. And actually yesterday evening I had another conversation with him over the phone, so we still talk to each other a lot. He basically invented a concept called planetary boundary. Basically saying that we are consuming a lot of resources, we are intervening with the nature so much so that we have gone beyond a red line in some cases. So first thing he did is that he identified what are important. In the beginning, there was only 9 areas. Now it's a little bit more. You can see climate change, for example, is one. You can see the integrity of biosphere. Basically, biodiversity is another one. And then they tried to actually to identify where we are. If we are in the green area, he said this is green, safe operation space. If we are in the yellow, then we are probably in an alarming stage. If in the red, we have gone cross red line. So you can see that we have already actually crossed some of the red lines. So we are changed deeply the environment and the Earth system. And with that input, the UN Secretary General, the former UN Secretary General made a statement which I think is very nice. He said basically, so we have our foot on the accelerator driving towards the abyss. So basically a warning signal. And of course, even current UN Secretary General made a similar statement about the global warming. And so we are in a quite serious situation. And before I'm going further, talking a little bit about history, I want to explain a few terms so you understand what I'm saying. And when we're working in science, we have our disciplines. So we can have a unidisciplinary research or work. So basically then you are working in your own discipline, for example. I'm working on my discipline. Then we could have a multiple disciplinary work. That is, we work together from different disciplines. And more important, Earth system science is the latter. It's called interdisciplinary science, meaning that we are actually interacting with each other. Not only just we work together towards the same goal, but also we are interacting with each other. So we work really together. So that is the important concept. But then you said, why we need interdisciplinary work? Well, if you look at that number, you understand. For example, if we look at the disciplines, number of disciplines in the university system in the world, you can see that, if we start from 1,300, it's only 7. In the old days, you only have philosophy, etc., mathematics, art, and so on. But in the 1950s, you have only 54. And that is 2011. It's already exceeding 8,000. So with all the challenges we have, how can you use all the disciplines? What do you need to use? So in that sense, you can see the need to kind of integrative science. And also because we have some advancement in complex theory, because all these are complex. Interconnectiveness means complexity. I will show you a little bit examples of that. And finally, of course, it's important to study, but when you're working towards solutions of problems, there is maybe only one solution. We all need to work together. So you can see from that number and statistics easily seeing the lead of interdisciplinary work. And also we need to have international science. That's why you are here, I think. And also that's why you should continue with your journey. Because we really, one country, one nation will never be solved all the problems we're facing. There are global problems like climate change. And there is same question to the Nobel laureates, as I mentioned before, asking them and what importance of working together and basically international mobility. So people like yourself travel from one place, one country to another, and to work, to study. And you can see that most of them answered yes, that is absolutely necessary. So I also personally strongly believe in science, we have to work together. Of course, in other areas, we know there are a lot of challenges nowadays, but in science, we have no choice. So with that slide, I'm going to tell you a little bit of the history of the Earth system science with my own experience, my own perspectives. And of course, it started a little bit earlier. In the very beginning, I listed, for example, IGY, this is International Geophysical Year. The Keeling curve I showed you before was started in 1957 because of the International Geophysical Year. And so there are, but these are still quite small scale. The really big scale global research program on global change started really in 1980. And it was initiated by somebody called Pat Boning over there, and a few others, but he's the most important person. And Pat Boning is a professor in Stockholm, and he was actually the supervisor of my supervisor. And so it's quite interesting that later on I became his colleague, and we worked together for many years. So he actually started in 1980 something called the World Climate Research Program. And of course, at that time, I'm still a student. And I was second year in the university. So I graduated from Nanjing University in China 3 years later. But I already heard something from my professor telling about this program. And then, interestingly, that this program is mainly focused on atmosphere and the ocean. Later on, they realized actually it's not enough we focus just on atmosphere and the ocean, but also we need to look at the surface of the Earth. Look at the urbanization. We build a lot of structures, we change the land surface in a fundamental way. So then International Geosphere Biosphere Program, also we are changing the biosphere because you see the agriculture, larger scale agriculture, we are replacing the natural ecosystem with larger scale quite often single structure of the plants. We also deforestation. We deforest a lot of places in South America, for example. And we actually replace the natural forestry with quite uniform agriculture for economic benefits. And so the International Geosphere and Biosphere Program has done a lot of work in that area. But you can see these are still natural science. And then, of course, the people find that biodiversity is a challenge. So we created something called Biodiversitas. It is only in 1996 the international community realized we have to consider humans in the system. This is also about the time Paul Crutzen and a few others invented the concept of Anthropocene. So with that, they created something called the International Human Dimension of Global Change Program, IHDP. With that program, we started to think about humans' role in the system. And actually, it's only until 2001 in Amsterdam, there was a big meeting, very important meeting, landmark meeting, where we defined the Earth system. So this is quite a new concept. And at Tsinghua, actually, university established Earth System Science Department in 2009. In the beginning, it was not a department, it was a research center. But this is typically in the university structure, you cannot start a department immediately. And you need to recruit staff, you need to get students and so on. But Tsinghua is very fast in creating an Earth System Science Department. And so In 2009, actually, that year is important. I joined the International Science Council. I became the executive director. And so when I became director, I was in charge of all these programs. So we have a look. We said that we need to do strategic planning. And we did that. We agreed on a vision for the next decade, and we created something new called Future Earth. So if you are interested in the development in this area, you can have a look at Future Earth, which is the largest research program on environment on the Earth in the world at the moment. And the mission of Future Earth is really to accelerate research in support of transformation to global sustainability. So that is the mission. And Future Earth basically focuses on the nature and human interaction. You can see the importance of human and nature interaction. It has been organized in different ways, cross-cutting different disciplines, focus on some theme areas such as land, ocean, atmosphere, etc. and governance. So there are many, many different research projects. Health is also an important one in connection to what Professor Huang has told you. And so 3 themes in scientific research. Number 1 is we need to understand how the planet is evolving, the dynamics. The second one is to look at the global development. So we need to look at the people, how their well-being, the economic conditions, living conditions, how this has been changing. And finally, we all need to transform the society into something more sustainable. I think I skipped that part, and just telling you that actually after 2 years, we came up with a very vision about this, and we said that we need to develop Earth system science for global sustainability. And we published this paper. This paper has become the key idea, concept of Future Earth, which I told you before. In essence, and we have seen a mindset change in the world over years, starting from 1972 in Stockholm Conference. You know what is sustainability? Well, you have 3 pillars in sustainability. Number 1 is economic, number 2 is social, and number 3 is economic. And typically, we define the 3 pillars as equal. And then in the intersection part, we said this is sustainability. So we need to have, of course, economic development. We also need to take care of the environment. And finally, we also need to take care of social structure so that we don't have a very diversified or polarized world. The poor is becoming poorer and the rich become richer. We need to have an equitable and a just world. So that was the idea. But over years, we realized that actually that was not really true. So in 2017, I published a paper basically saying that we need to look at the whole thing in that region. That is, the environment actually is the biggest thing. Actually, the Chinese President Xi has made a statement quite similar to that. And in the beginning, of course, in the 70s, in the 80s, China also was in a development phase. Many people said, we first develop economy first. We pollute the environment, then we'll fix it. But now in China, at least, I think they realize that we have to think at the same time. And also, we only have one environment. So environment is the biggest thing. Then also, we need to think about the social. And so the unjust and also inequality issue. And finally, of course, we still need to think of economy. But economy is really embedded into the social structure, and also embedded in the environment. And that is a mindset change. That is very important, I think. I hope this will go into your heart and also in the heart of the people in the world. So I promise to tell you 5 grand challenges we come up with, and which is not surprising. Number 1 is that we need to increase our capability to be able to predict changes, prediction. And any science, the final goal is to be able to predict. That is very important. So how we do that? We need to develop models. We need to use AI, for example. And number two, we still need a lot of observation. And you might think we have already a lot of data, but actually we don't. So for example, in the social behavior, human behavior, we don't have much data. And we still need a lot of data. Number three is that we need to look at the critical thresholds, because in the system is non-linear, meaning it can have a sudden, abrupt change. So you have critical thresholds. When you over that threshold, you can experience a large and dramatic change. We need to find that. We also need to look at how we respond to these problems. So the governance is a big issue. And finally, we also need to be more innovative, because through technology, for example, and also through social transformation, we can actually do better job. So there's a dimension here also. These are the 5 grand challenges. I think we are working in all these areas. I'll give you a few examples before I conclude. Number one is a work we did recently, for example. Now, energy is a big issue. We need to find renewable energy. And then we came up with the idea that we have a lot of reservoirs in the world. The reservoirs is losing water through evaporation. If we cover reservoir with solar panel, you can produce a lot of electricity. You will reduce the loss of water. So it's a win-win. It's really a good idea. I was in Shenzhen, I told you, in southern China. The city is big, it's really modern, and it's developing quickly. But they have a reservoir. We did a calculation for them. If they cover their reservoir with a solar panel, they can supply almost the whole city's energy need. Can you imagine? So this idea is now a lot of work are going on to implement this idea. And but we came up with some concept and also calculation. I think this is part of the Earth system science, because we need to calculate how the water is lost and how much energy you can get, because you need to understand how much solar radiation we have. And skip that part. And I still want to make a statement here about what is the difference between Earth science and Earth system science. Because even in Chinese, sometimes it's confusing. In Tsinghua, we call it 地学系, because it just sounds like it's an Earth science department, which is not true. Tsinghua is the Earth system science department. What is different? Well, Earth sciences, as I told you before, is about oceanography, it's about atmospheric science, it's about biology, it's about geology. Actually, in Tsinghua, we don't have geology at all, for example. Earth system science is different. It's an integrative science, and also it's based on complex system theory. And also it's focused on the human influence of the system. Because in geology, they're looking at a much longer time scale, as I showed you before. And that's why geologists always say, don't worry about climate change. We have climate much hotter than that some millions of years ago. But that's not relevant in this case. And also, in Earth system science, we try to serve the sustainable development of the world. That's a big difference. So what is complex system? And well, that is, of course, I can easily give you 1 hour lecture about this with this diagram, but I will not, because I just to tell you that the complex system really is also quite similar to, can be applied to different systems. It also can really be integrative. And it's also provided actually a lot of theory for what we see in a complex system. And we wrote a paper actually in 2021. You might be wondering why, but we did that paper in Chinese actually. It is because that year we gave Nobel Prize in physics to 3 people, who are climate scientists, at least 2 of them. One of them is a little bit climate science, a little bit of physics. And I hope I have, sorry. It is a little bit of disorder. So let me try to get to the, yeah, this is a picture, 2021. We give the Nobel Prize in Physics, and the Nobel Prize is given by Royal Swedish Academy of Sciences, and we typically discuss, we make a decision, and as I told you, then we make a phone call to the prize winner, and somebody then walk out of the room to tell the journalist why we give the prize to this person. And that year, I took the honor to tell the Swedish journalist about why we give the prize. And so Swedish journalist has the right to know first. So typically we talk to the Swedish journalist first, then we talk to another media. Here is another Chinese media, for example. So why we give this is because the 3 people has contributed to the complex system theory, especially to the climate science. As you know, that climate science, to get the Nobel Prize in physics is not that easy. Physics has a lot of really hard physics, but at least this is a proof, I will say, that the climate science, Earth system science has become one of the most important science in the scientific world. And in the introduction, and the chair actually told you that I was coordinating leader also of IPCC report. So in the last report, also 2021, and we made a history of climate science, which is very similar to Earth system science. And of course, again, with that diagram, we show the whole history. I can talk 2 hours easily with this diagram, but I will not do that. I just to show you that 3 things are important in science, which you are paid attention to when you study in the summer school here. Number 1 is that observation. Data. So in all science, when you start with your science, pay attention to observation, the data. That is the starting point. The same with climate science. Number 2 is that you need to have some theory. And that theory can be actually from observation, from laboratory or from modeling work. So in climate science, in the global warming science, it was started by Fourier, who is a very famous mathematics, Fourier transform. And he did this experiment in laboratory about how carbon dioxide can track the heat, warm the world. So, and of course, in the last 2021 is the system science. These 3 Nobel Prize winners, I showed the photo there again. And it's also about the integration. For example, we also give Nobel Prize to economic person here. He's the guy who got the Nobel Prize in economics. And by integrating very simple climate model, a system model, with macroeconomics. And then, of course, then you can talk about the cost of mitigation, the cost of cutting emissions, etc. So that is also a sign of the importance of system science. World Economic Forum, I told you, this summer we were in Davos, in Tianjin. It's called Summer Davos. Funny enough, the name is Davos Summer Forum, but in Tianjin, held in Tianjin, just 200 kilometers, 100 kilometers from here. And so I was there, and basically we're setting agenda about something called climate resilience. And this is a new concept, also out of the Earth system science. And I'm sorry, that diagram I did not have the possibility to replace it in English. So, but I show you very quickly that what it is. So when you have a complex system, then look at the diagram. If you have a disturbance, for example, extreme events like hot weather, you have an energy system. Then usually the energy system, the performance will become lower. Sometimes it can collapse also. but then eventually it will recover. So climate resilience is about first to be able to resist to the disturbance. Number two is that has some capability to be able to adapt to the change, so adaptation. Number three is that it has the power to recover from the disturbance, also quickly, not only just slowly recovering, but also quickly. And finally, if you do this properly, you probably can transform the whole system into something totally different, into something that is actually better, perform better than before. So this is a fantastic concept, I would say. And I tried to talk to a lot of business leaders in that forum, political leaders. I think they love this. They love the concept because it's easy for them to implement their actions with that concept. I say a few words about big data, and because I promised to say a few words about future perspectives. The AI all need big data. Big data, actually, the first diagram before that, I want to show you that big data is not just about size. It's also about variety, different kinds of data. And so here I show you one example. We did a study. I'm a climate person. Can you imagine? We connect data on education, on children's education, on rural, city, urban difference in China, for example. We look at the water, fresh water, health, every data, kind of data we could connect about China. We want to really to use the data to show China's development. And so what we found is that actually over the last decades, China's economics has been developed very fast, as you can see. The same is also with the environmental degradation. And the two are coupled. So this line, the blue one, is showing the coupling of the two. But the coupling actually started to be stabilized and then started to be decreased. Meaning that the economy can still grow, but you don't need to suffer at same as before, the environmental degradation, which is fantastic. When we saw that diagram, we were very excited because we see also the potential of this to be used in other developing nations, which is hopeful. Because in the West, we all believe that for the economic development, you need to use more energy. You need to have more environmental degradation, which is happening everywhere. But China has really shown it is possible to develop the economy further without further degrading the environment. And I had another diagram, it's even more exciting, which I could not show you again with the PowerPoint slide problem, which is, as you know, that China has become #1 emitter in carbon dioxide some years ago. US used to be the #1 for many, many years, but now China is #1. But, you know, in order to solve the climate crisis, we have to stabilize, we have to reduce the emission. And China promised to reach the top in 35, I think. But now it looks like in the last few years, the carbon emissions has been kind of stabilized, even show a little bit decreasing. When we showed this diagram in the economic forum a few days ago, people were so excited. But of course, it's just a couple of years, we'll see, because you need more years, more data. If this is continued to be the case, I think it will be a fantastic story. And same as here. So you can use big data, you can have different data, and to look at whole issues. This is another data, we look at the education between female and male in China. You know, especially in the countryside in China, traditionally the male has a very important position than females because they are neighbors, they are heritage from the farms and so on. And there's a tradition. And also there is an influence on the education level of female and males. So we look at that. But with time, you can see there is a lot of improvement. So this inequality has been decreased a lot, which is, again, a very positive sign. And you have not experienced maybe in China, it's very easy to buy things. Shopping is very easy, just to use an iPhone. It's very quick. That means there's a lot of transportation. So we studied also with data. All the data, actually, all the vehicles has data to be connected. And we look at all this data, we look at how this carbon emission has been transferred from one place to another, which is it's impossible just some years ago. So all kinds of data. And we also look at the hydropower. Hydropower is a clean energy. And with today's data, we studied almost 3 million sites in the world. Can you imagine 3 million? And it was done by a PhD student. But with big data. We look at not only the water conditions, the elevation difference, but also we look at actually the cultural heritage, the biodiversity, and how much carbon emission you would result if you produce a dam in this region, etc. Many, many factors, which is beyond my imagination. It's done by a PhD student. So I think all these are big data, and also I told you energy system can really be disturbed by extreme events, and we also developed concept and solutions. And one of my PhD students recently published a work with wind energy, and predicting that if you have volcanic eruption, the global wind energy could be reduced by 8%, up to 8%. Because as you can see, the wind has been declining, the wind speed. So many people was worried, can we still develop the wind power? But then in 2010, the wind speed is picking up again. And people say, okay, it's hopeful. And then we thought maybe in the future, we have not done the prediction about volcanic eruption. We only did the prediction for carbon dioxide increase. So we did that work, which was published in a new Chinese journal called The Innovation. I have to say a few words about this journal because this journal is actually organized by a small group of young scientists in China. Within a few years, they become much more powerful than most of the Nature family journals. The impact factor is something like 35, I think, if you have some feeling about impact factor. So I met with the chief editor. I was really impressed by this young group of people. And wonderful. I think with young people, you can do a lot of things you can not imagine of. And recently, also in my own department, we published a paper in Nature and with a young staff and also some students actually. We look at the whole energy system in the world, the renewable energy system, and what is the best strategy to develop or not develop. So this is, I think, very useful for the future sustainability in the world. And finally, I'll say a few words about AI because I did something. We have a professor in Tsinghua also, Professor Qiu Zhengtong. He's a fierce medal winner. It's high surprise in mathematics. And he used to be a professor in Harvard and joined Tsinghua also a few years ago. And he did a prize in basic science. And then he asked me and a few others to help him to create a new prize for environmental science. And so I look at the AI, how AI has been used in my own area, weather and climate. And we found that actually there are a lot of models that has been developed. And for last year, we choose actually a group from Huawei. Huawei is a Chinese phone company, very successful. It's my hero. And so I still use the Huawei phone, although it is very difficult to use it in Sweden. Outside China, is because US and it has decided to abandon the company. But it's very useful. And they also have a division developing AI technology for weather prediction. They did a fantastic job. In the middle, the three gentlemen who won the first prize of this environmental part of the basic science prize. I was also involved in another group in Shanghai, which I'll show you. In Shanghai, another AI group called Fuxi. And we developed weather prediction even for longer scale, up to 60 days. Can you imagine? We did quite successful 60 days weather prediction. And this is a diagram showing the success. We beat the best prediction models in the world, which is ECMWF, the European model. So AI has a lot of potential, actually. I skipped that work. It's also another work, but just to show you another more exciting work, which is in our Earth system, everything is connected with each other. So we look at the tipping elements, and we identify one tipping element in Tibetan Plateau, and we show that tipping element is linked to what's happening in Amazonia, rainforest. And also rainforest in Amazon has been linked to Antarctic sea ice change. So everything is connected to each other through the system. And this is also done by a student that I co-supervised. And the paper was published in Nature Climate Change as a cover page, actually. It's highlighted by Nature. I think I'm going over time now, so I think I stop here and ready to answer questions of you. Thank you.